Go ahead and share my screen. Okay, so the first thing that we want to do is we want to reiterate what exactly security architecture is. Now, as a reminder, when we're talking about security architecture, it defines how an organization protects its asset. Remember how last class we said it's the how? Well, in this case, it's still the how, except we're going to dive a lot deeper into like the intricacies of the how, I guess you could say. Now, when we're talking about the how, it's talking about the different technologies that is being used, the different policies and standards, and the different practices that different teams are going to have to do in order to secure their assets. At the end of the day, security architecture is to protect assets of the company. Remember, assets is not just documents, it's not just proprietary information. Employees are also assets. And as you remember me saying time and time again, your number one goal in cybersecurity is to protect human life. Okay? So I like to always think of like an architect of a blueprint. Like the blueprint is essentially dedicated to understanding how security is structured in the organization. So we'll be talking about things such as what the threats involved are going to be and how we can protect against those threats, whether that's past threats or current threats. We also want to understand the business dependence, so why it's really important, followed by compliance and reputation. As a reminder, compliance and reputation is tied to you as an organization and how well you fare to your stakeholders, to the board of directors, and to investors. When you're compliant, you essentially have a stamp of approval. Reputation is your reputation in the industry, both in the security industry as well as in the customer industry, right? In the customer's mind. So you want to make sure that you are in compliance with all of those so that you can avoid things like regulatory fines, data loss, and potentially brand damage. We'll talk more about um, the network topology. If you don't know what that means, it's just like a diagram of a network. We'll talk about defense in depth, essentially like how you can have a lot more controls. Now, the entire idea with this whole thing is to have you learn these, okay? It's to have you to understand the different risks associated with cybersecurity and assets to prioritize. So this is directly correlated to compliance because there are going to be some things that are going to need to be protected more than others. And then there's designing the infrastructure as well as implementing network security tools. If you remember last class, I said one of the foundations of cybersecurity is networking. The definition of networking is sending information from one device to another. So sending that information from one device to another is critical because you want to make sure it's being sent securely and you have the right infrastructure to protect all that data. Now we're talking sending information from one computer to another. That's pretty rudimentary and simple, right? If you put it into an actual enterprise or a business, think about that sending information to one another, except it's maybe 1,000 different computers sending information, not just to one another, but to each other. So there's information going everywhere. So you need to have a security architecture so you can visually see where the data is going and how you can protect the transmission of that data. So that's in regards to the security of communication. Access control, as a reminder, is one of the key components when it comes to cybersecurity because that's how you protect who has access to what. When you control who has access to what, you lower the likelihood and impact if an incident were to happen. So let's say if Farah was an employee, a marketing employee, well, then she would only need marketing employee assets and software. That's it. They don't need anything else. If you have more than that, and then this would never happen because Farah is very secure in all of her work and everything. Well, then if Farah were to get breached, maybe by accident by someone, well, then she would not put the company at risk because she has access control set in place. She has the concept of least privilege, the principle of least privilege. Not only does the principle of least privilege apply here, but it also applies when it comes to the zero trust principle. As a reminder, zero trust stands for, here we'll ask, what does zero trust mean? Answer in the thread, please. In the thread. What does zero trust mean? See some replies. Never trust, always verify. I am so glad you all are paying attention to my classes. That is awesome. That is absolutely correct. Zero trust just means never trust, always verify. So any communication that happens within your network, anytime anyone is communicating, well, then you want to never trust and always verify they are who they are. A verification can be a simple check saying, hey, are you say who you say you are? Do you have access to this? Just double checking. It never hurts to just double check. Okay? It never hurts. Thank you for those of you who commented in the thread. Let's keep that up. All right, so let's move on now and talk a bit more in depth about what I like to call resilience. Now, if you remember, the CIA triad stands for confidentiality, integrity, and availability. The concept of availability is centered around making sure that all of your assets and all of your software and services remain online and accessible to all of its intended users. A simple way to think about it is Gmail. If you have Gmail, MSN, Yahoo, whatever you want, right? An email service provider, well, the availability of that service means that you can log in, send emails, read emails, and just use the platform. If it is not available, that means that you cannot access it. As a business, if your intended users cannot access a platform, you're losing money. So availability is just the practice of ensuring that your data and your systems are accessible to the authorized users when needed. Now, authorized users is important here because just because we're talking about availability doesn't mean that we negate confidentiality. We want to make sure that it's still only available to the authorized users. That's a very important part of the availability framework. Now, on top of availability, there is something that we call resilience. Now, resilience is a really important piece of what we call GRC. GRC stands for governance, risk, and compliance. You can become a GRC professional because a piece of that is in resilience. Resilience is the ability to continue operating as business as usual or quickly recover if there is an incident. That's all resilience is. It is a measure to say, hey, can we still operate? Is our team still able to function even if there is a security incident or anything like that? Now, I say security incident, right? It could be a cyber attack. It could be a malfunction in the network. It could be a natural disaster like an earthquake or a fire, or it could be human error. Anything that could cause operations to stop in a business would be considered an incident. The antidote to that is having a strong resilience program. Now, the resilience program is centered around one thing and one thing only, making sure that A, people are safe, and B, that the business can still function. Depending on which organization you're in, sometimes they break resiliency into different departments. So one of the departments will be crisis management. This will be the physical safety of the employees, meaning cameras, what to do if there's an earthquake, what to do if there's a fire, making sure that people are aware of these. And then there's also what we call BCP, which is the business continuity plan. That is directly exactly what it means. It is a plan that details out what exactly you need to do if you have a business, if you want your business to continue. And the last piece, which we'll talk about, is this one right here, disaster recovery. So disaster recovery, in essence, is just a comprehensive strategy or typically a document that restores operations quickly after an incident. Now, keep in mind, disaster recovery is a very technical piece of resilience because you need to be able to understand backups. You need to be able to understand how systems work. And when you do all that, you have to put a plan in place and have buy-in from all the businesses to say, hey, if there is a bunch of traffic on our main website, we need to have a failover so we can redirect traffic so that it's more balanced out, something like that. There's also redundancy. That means having backups on backups on backups. It means preventing a single point of failure. So if you're communicating with someone, well, then if that line of communication cuts, that's a single point of failure. If you're communicating with someone, but you have multiple ways to communicate with them, well, then that is redundancy. It's being able to still accomplish the task or still able to function, even if one of those lines of communication are done or is unavailable. There's regular testing. So regular testing in very simple terms is just making sure that you're conducting tests to make sure that your backups and your recovery procedures are working. Now, when it comes to BCP, it's not done as often because no one thinks that it's as needed. If you think about BCPs, which a reminder is business continuity plan, you're essentially telling people to do work on something that could potentially happen. And people want to do work on things that actually make an impact. It's until it's too late that they realize, oh, we should have put proactive work into the BCP. Now, employees and companies tend to put a lot of work into disaster recovery plans, though, because they do want to have redundancy. They do want to have backups. They want to make sure that they're verifying the effectiveness of all of these programs efficiently. Now, you might be saying, okay, we're talking about backups, we're talking about redundancy. Well, what kind of tests do these look like? Well, the test could be like a backup restoration drill. So it's typically when you pretend like an event happened and you have to back up a system or make it come back online. That's an example. There's also a failover simulation. That means if one of the servers fail, can we move all of that stuff to another server? And then one of the ones that's one of the easiest things to do is something called a tabletop exercise because it does not require a lot of technical work. It doesn't require a lot of technical movement. Instead, you sit at a table, like it's literally a tabletop exercise. You sit down with all the employees and then you run through a scenario. You say, okay, on right now, what just happened is there's a fire in the server room where all of our content is hosted. We need that content to push into our software to work. Well, they say, okay, what do you do? This is a point where people say we do XYZ. Yes, Abdul, it is essentially running a playbook. More often than not, when you're doing a tabletop exercise, well, then the employees should know or at least understand what the basic steps are. At the very least, they should know where to find those steps. Because keep in mind, when an incident happens, you're taking the human component into consideration, meaning employees they get emotional or they get a lot of adrenaline when something happens. So an example is during an earthquake, everyone is worried about their safety. So their heightened level of awareness. So you need to have a document that's simple, easy to read, and direct in order for you to be able to measure it accordingly. We'll talk about disaster recovery a bit more, but later on in class. But I would say one of the things that you can take with you when it comes to availability is um, is it possible that a backup had a virus malware that was patched on the next patch, but because you ran the backup, the virus malware came back? Hypothetically, that is a possibility. However, Martial, typically when you put these backups in place, they're typically scanned, they're typically reviewed, verified, they typically go through a quality assurance process, meaning that they are deemed as good backups. So they go through a review process. Good question. So what are some ways that you can keep high availability? What are some ways you can do that? Well, one of the first things you can do is use what we call a load balancer. So a load balancer is a way to distribute traffic evenly so that it doesn't stress out one specific server all the most. Now, let's use, for example, a web server. As a reminder, a web server is just a server, which is just a computer or a computer dedicated to hosting your website. Every time you use a website, a software, anything like that, it is essentially going to another computer and giving you the contents of that computer. If that web server is getting a lot of traffic, it'll get stressed out, potentially crash. So if you put a load balancer before it, we'll talk about zones later, it can distribute that traffic a little more easily. Now, that's just one of the ways. There are a bunch of really other good ways to keep it available. However, there is a major factor you need to keep in mind, and that is cost. So when we're talking about networking, when we're talking about cybersecurity, keep in mind that we are talking about resources. So human resources that you're using um, to actually implement these things. We're talking about hardware. We're talking about um, we're talking about the different I would say, I would call it, we're also talking about the different costs if there were to be an incident. That's why cost considerers are in mind. An organization, they have to make smart decisions on how they're spending money to maximize the protection of their assets as well as cause as little friction as possible. Now, if you're a business owner and you think about this, it makes sense because you want to make sure to not have any breaches occur, but you also don't want all of the security measures to cause inconvenience. There are some companies that have, anytime you log into a website, right? Typically, you have your username, password, and then good companies will have two-factor authentication. Like you get it on your phone, your email, something that you have, right? Other companies that work with very sensitive data has something like 7 or 8 two-factor authentications. So you have to do username, password, then you have to use your phone, then your email, then you have to use an actual multi-factor authentication tool like Okta. And that can become cumbersome. Of course, if you're working with very sensitive data, that's important. However, if you're not, well, then it creates friction and doesn't actually allow people to do their work. This is why the ROI, which stands for return on investment, is important. Yes, it is money related, but it's also time related. So when you're taking into consideration your security architecture, you also have to think about the measure of value that the security investment would bring and comparing the cost of implementing the control or the potential loss if avoided, aka a breach. Typically, this is calculated by professionals and the finance team and IT team. They all come together and say, okay, this is how much we're spending on cybersecurity every year. This is the cost if we were to get a cybersecurity breach. You'll find that those breaches tend to be very expensive. Not only is it expensive because we're losing business, but if we have a data breach, well, then we would not be compliant with government regulations. That means the government could fine us. That means that the end users could fine us. Even if, for example, in GDPR, if you breach GDPR and you don't adhere to it, well, then the user can go ahead and report you, and then you could lose 3% of your profits. 3% is a lot of money for big organizations. So the first element is ROI. The next one is total cost of ownership. So total cost of ownership, also called TCO, it it's not just like purchasing something, okay? It means the setup, how much it takes to install it, the different licenses or subscriptions, how much time you're going to have to spend training your staff or implementing it, ongoing maintenance and updates. Keep in mind, cost of ownership here. Let's say, for example, you want to buy a security software service that allows you to monitor your network a lot more closely. When you do that, it's going to take time and cost. You're going to have to implement it. It's going to have to connect to all your servers and whatnot. So you need to keep that in mind. However, when you think of total cost of ownership, an easy way to think about it is it helps compare long-term cost versus short-term expenses. Okay. Budget allocation, it's pretty simple. Every team has a budget. So when you have said budget, you have to go ahead and keep that in mind when you're making expenditures. All right. So what are some ways that you can essentially optimize your cost? Now, think of this. Right now, we were talking a lot about being what we call an individual contributor. That means that you're a cybersecurity resource that does specific tasks. If you're, let's say, a CTO, CIO, or a CISO, that means Chief Information Security Officer, all of these titles have to keep budget in mind. So ways that you can save on money for your budget is essentially things such as using open source tools. Open source tools are really powerful because they tend to be cheap, they tend to be community supported, and they tend to be free. That's one of the biggest things is they tend to be free because they're not owned by a corporation. For example, Microsoft has a bunch of cybersecurity tools. However, they're not open source, they're proprietary. Whereas other tools such as Linux is open source. So it is community oriented. The other one is on-prem versus cloud. If you remember, we talked about that last class. With cloud, with on-prem, you have a lot more control, but it is more expensive. With cloud, it's essentially renting a service. It's like a pay-as-you-go, pay-to-play type of subscription, and it reduces a lot of admin costs. It tends to be a little cheaper, but you are foregoing control there. And the last way to essentially minimize your risk is to try and automate it. So I bring this up because in this day and age, automation is one of the most important pieces of running a cybersecurity team that's efficient. Okay. All right. So let's talk a little bit about scalability. The definition for scalability is a system's ability to grow or shrink depending on business needs. What does that mean? So, a very simple way to think about it is if you're a startup, right? That startup is going to get new employees. When you get new employees, you have to add new computers. That's the concept of scaling, where you start out small, but then your team grows, 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 grows. That's called scalability. When you grow, you want that growth to be as simple and easy as possible. You don't want to sacrifice performance. You don't want to sacrifice this major redesigns because when you build something, you should build it with the idea that it should already grow. Okay. So that's scalability. Now I'm talking about a team growing with a bunch of computers, right? If I'm a security engineer and I want to make sure we're scalable, well, then I'll buy more computers that are needed. I'll buy a bigger space than is required with the concept that we can grow into it. And I try to make it so that at no point in time will I have to redesign the entire architecture to be able to accommodate more new employees. The next one, I talked about scalability. I do want to define responsiveness. Responsiveness is the ability to adapt quickly to new threats. That's the simple concept of it. It's being able to adapt quickly to new threats. Let me check here real quick. Okay, Andrea, I see your note. I'll have to get back to you on that. So if a bad actor infiltrated the source of, would the community revolt against them? That's a very good question. So the idea Brian is asking if a threat actor gets access to the open source code, well then would it affect the entire community? Hypothetically, hypothetically, yes. But I will let the TAs answer that because I think that one deserves a more thorough answer. All right. So, what are some key elements of scalability and responsiveness? Well, the first one is a flexible design. A flexible design means that it can handle more users, more data, and more devices over time without breaking. That's all it means. Now, when I say more data and more technology and more devices, that's like saying, okay, I'm going to pack. And I'm going to make sure that when I pack, my suitcase is going to be bigger so that when I travel, well, then I can buy souvenirs and there's still space in my bag to bring back. That's a very simple concept of flexible design, meaning that you can add or remove things as needed. The other one is making sure you have automated solutions. The more automation you have, the more time you're saving. And then the last one is cloud integrations. So cloud integrations excuse me, cloud integrations is essentially being able to have a cloud infrastructure that doesn't allow you to buy physical devices. Excuse me. Instead, you can have an infrastructure that has logical devices in place so that you can scale accordingly. This is one of the benefits of cloud computing is being able to kind of scale as the business needs. All right. Now, what are some strategies that you can use? I already talked about cloud services, right? So as a reminder, the big three are AWS, Azure, and GCP, which stands for Google Cloud Platform. And then there's the concept of visualization. So virtualization, as a reminder, is when you can have a computer within a computer or a container that contains applications. That's from the last class. So that's really, really good because these are scalable, these are flexible. That's one of the powers of cloud computing when everyone is rushing towards them. The next one is using, you guessed it, AI, artificial intelligence and machine learning. This is important because when you use artificial intelligence and machine learning, well, then your security tools can become stronger and they can become more dynamic. They can learn faster. Okay, let's talk about ease of deployment and recovery. So ease of deployment in very simple terms is how easy is it to set up and configure our infrastructure. So the concept of deployment means that I want to make sure that if I'm going to include this new tool, this new software, I want the setup to be seamless. You don't want something that's going to take months or years to implement. You want something that's pretty quick and efficient and easy to use. Now, the other concept is ease of recovery. Ease of recovery is how quickly can you restore normal operations. This is in relation to disaster recovery planning. Okay, so it's directly correlated. So, what are some things that are important when it comes to ease of deployment? Well, the first one is making sure that you have user-friendly solutions. What does that mean? That means that you have tools that are easy for the staff to learn. That means that you don't have to train them as much. It needs to be intuitive. It needs to make sense. This is where the UI, the user interface, that's just the screen that you're looking at and being able to click buttons and do XYZ. So that's why it's really important because you want to make sure that it's user-friendly, simple to use. Then standardized procedures. In very simple terms, standardized procedures is just making sure that you have a checklist or you have a template of things that the employees can use. You want to minimize the customizability of these tools as much as possible for the end user. You want to make sure the end user knows exactly what the tool is for and exactly how to use it. The reason why is because it helps you to deploy and restore the systems faster. And then staff readiness. So staff readiness is what I mean when we're talking about training and awareness. You do have to include time to train your users, make sure they understand the program and how to use the program. That does take time. However, it's important because keep in mind, when you're implementing a new tool, it's not for the IT team. It's not for the security team mainly. It is for the end user to understand and know how to use. That's all it is. All right. Now, the opposite of these, I would say, is if you have a complex tool. So if you have a really complicated tool, well, then it can become a bit too much. Then users would be like, oh, that's too much for us to handle. And then you could have it where the recovery takes longer because it's so complicated and they don't understand the steps. That's why it's important to have standardized processes. And the last one is a longer downtime. So if you have a longer downtime, well, then that could impact business continuity. It could be having a risk, regulatory risk, and customer loss. So, what are some strategies to simplify this? Well, one of the first things you can do is, again, automate it. If you have a user-friendly interface and you have an automated deployment feature, well, then it makes it easy to kind of manage. Okay. So one of the tools that I would suggest you all check out is this, is a great automated deployment tool that you can look into a bit more. And then the next one is make sure that you have standardized documentation. That's all this is, making sure you have standardized documentation. And the last one is making sure that you test regularly. These are all the steps that you want to do when it comes to deployment and recovery of new software and systems. Okay, now let's talk about infrastructure. As a reminder, when we're talking about architecture, it's the design, it's the plan. When it comes to infrastructure, it's talking about the actual devices, the actual softwares, the actual things that you're trying to implement. Now, poor infrastructure means that you'll have a bigger attack surface. You'll have more downtime and it'll be difficult to respond to an incident. Okay. Let's take um, and then an easier way to think of infrastructure and why it's important is because when you have a good design, well then A, you're more secure, you can respond faster, and then it's easier for you to cover if there's an accident. So let's take this castle, for example. In this castle, you'll notice a couple things, right? So you notice there are high walls here. You'll notice there's like a barrier here. You'll notice that it is layered. There are layers of security. So when you have like not just one door, but two, when you have like these like guardrails here, if someone is able to get into this section, they'll still have to go through this section. And then here, there's a staircase. It's all in an effort in a design to make it more secure and for people to respond faster. So one of the reasons why castles were so great and why they were really helpful is because when you have archers up here, they're able to take out the enemies. And then if one of the doors get breached, they typically have like a back door where they're able to go into the other layer where then they can still shoot the people down. So it is a form of redundancy, I guess you could say, or another safety measure. Now, when it comes to the importance of infrastructure, there is something to be noted. Let me just double check the next one. Okay. So one of the important things to understand with infrastructure design is placement. So there is something called different security zones, right? When I say device placement, we talked about this a little bit, where you have a network. In that network, you have different zones. Those different zones contain different devices. So why is this important? Because a zone is essentially a network or it's a division of a network into a segment, okay? And so when you break these down, all of these different zones have different devices that are typically associated with it. So let me show you here. Network security zone map. So there's this one image that I like to show that's pretty simple. Now, keep in mind, this is a very simplified version. I'll show you two. So the first with yes, yes, Peter, yes. So this is the first one. So this is a very simplified version of the different zones that exist in a network. So first of all, I want to point out that on the outside, you have the internet. This is like the entire internet and whatnot. Then when you have the internet, you have what we call a firewall. Now, the entire goal of the firewall, which I'll explain more, is to not let malicious traffic in. Keep in mind that the firewall does two things. It ingests data and then it makes sure um, to filter data that goes out. An example is if I'm a threat actor and I work at the company and I'm trying to send an email to a competitor with all the company secrets. The firewall will note that I'm trying to send that based on very complex algorithms and reject that email from going out. It is a protective mechanism. So this is the outside. Then we have the firewall. The other zone is what we call the DMZ. The DMZ is called the demilitarized zone. The demilitarized zone, in very simple terms, is a secure version of the network that is accessible to the internet. So that means that you want people to access it, but it still has security features there within. A very common thing is to have your web server in the DMZ. The web server, again, is the server that hosts everything for your website, right? So the demilitarized zone hosts it so that if you're on the internet, you can still access it. Firewall says, hey, you're a legit user, go ahead and access the website. When you're in the website, you can browse around as needed. Now, the inside zone is essentially your intranet. That means only resources and tools that you as an employee can access. There are certain tools and information that only you should have access to, and it should remain that way. Okay. So this is a very simplified version of a DMZ. Now, if we were to look at a more complex version of a DMZ, it would look something more like this. So you have the same thing. You have the internet, then you have a VPN. There you have the demilitarized zone because it tends to be like your web server and then a VPN. And then you go into the intranet, whatnot, right? And then here you get access to a bunch of other features. Now, a NIDS, I'll tell you right now, that stands for Network Intrusion Detection System. So this is a security feature that says, hey, is someone trying to access our network? Well, now we need to know. As you'll notice, it tends to be in conjunction with a firewall. This is um, a very common setup where a firewall is placed before every entry point or every exit point of a zone. Next to it is a network detection system. Sometimes these are the same thing, they work together, but it is a security mechanism to say, hey, if I'm the internet, I'm trying to access the web server, well, then I will filter through the firewall, filter through the network intrusion detection system, go to the switch, and the switch says, oh, this person is looking for the web server. They will filter me to the web server accordingly. Okay? Now, this right here, I was incorrect. This is the demilitarized zone. In this case, if you have a VPN, well, then you can access another version of the web server, which is probably an internal one. And so let's say you're still the client, you're still trying to access that kind of stuff. Okay, great. Now let's say you want to access the internal network, same process, VPN, get into the internal network, yada, yada, what have you. Okay. But the important thing to understand here is there are zones that exist within a network, and each of those zones have very specific rules. Those rules can dictate internal traffic, external traffic, that kind of stuff, right? A very simple example is if I am outside the internet, I can't access HR records. That's just not something I'm allowed to do because the zones protect me from doing that. I think I defined these here. We talked about demilitarized zone, the DMZ. We talked about the internal zones, which are internal network. And then we talked about external zones, which is just the internet overall. Now, the device placement here is like I talked about, we have firewalls. So firewalls are one of the most important device structures that you can have in there because they can protect incoming traffic and outgoing traffic. Then the next one is intrusion detection system. That's what I called when I said a NIDS. So NIDS, it stands for Network Intrusion Detection System. Then there you have what we call an IPS, an intrusion prevention system. Now, I think we've covered this before in class, but just to reiterate, an intrusion detection system, IDS, is a passive detection system, meaning that if there's an intrusion, it detects it, but it does not do anything to it. It just detects it. That's it. An intrusion prevention system is an active one, meaning that it actually prevents the intrusion from continuing. A detection only like notifies someone that it's happening, whereas a prevention actively stops it. This tends to be more automated, and this is what we tend to see a lot of companies prefer in order to like not have an actual resource take care of it. Isolating sensitive data. So that's just protecting the data internally. So that would be like, say, here. Um, these are data servers. So in order to access the data server, let's say you're just someone on the internet, right? If you're someone on the internet and you want to access that data server because you're a threat actor, you would have to bypass this firewall, bypass this intrusion system, hit the right switch to be able to go to a proxy server. The proxy server is essentially a server that kind of like obfuscates who you are and kind of like gives you a proxy IP. Then you would have to hit the switch. You would have to go through two firewalls and another intrusion detection system in order to get to the sensitive data. This is important because if you're a threat actor, you have to bypass one, two, three, four, five, six, seven, eight, nine. You're going to have to go through nine different security devices in order to access that data. This is called layered security. You're protecting the sensitive data that no one should be able to have access to. Keep in mind, this is the red one. Stands for restricted zone, meaning the database here is really important. It could have something such as credit card information or whatnot. So this is kind of a nutshell of the device placement and security zones that exist inside of the network structure. All right. That being said, I think I've hammered that one home, so I won't kind of like um I won't kind of like go on that too much further, but these are the implementations. You need to take steps. One of the first things you want to do is you want to define the zones. And then once you define the zones, you want to make sure you set the right controls. So right firewalls, access control lists, meaning who's allowed to access what. Those access control lists tend to live in the switch. So the switch knows who has access to what. And then you want to keep monitoring it. Okay. Let's see here. Would this network architecture be costly? Would it be a large or anything like that? Yes, that's a very good question, Peter. That is accurate. It would be very expensive, and most enterprise accounts tend to have that. Could a security be maintained with IPS if there is no IDS in place? Yes, because most IPSs, intrusion prevention system, also serve as an IDS. They will notify the security professional if they actively stopped a threat. That way, the security professional can say, yes, that was valid, or no, that was not. Is this the same protocol ethical hackers use to find weak points for companies? You might have to expand a bit more on that question, Ali. Moving on. So, how exactly can you minimize um how exactly can you minimize attack surfaces? Well, to put it quite simply, you need to look at all the different ways an attacker would want to gain access to it, right? So one of the ways they'll do that is they want to enter the system, they want to extract data, or they want to essentially exploit vulnerabilities. Again, that's the attack surface, all the ways that they can try to cause harm. So what you want to do is reduce the attack surface or minimize the attack surface overall. You want to reduce the entry to this so that it minimizes the risk. That's the entire goal here. So what are ways that you can do that? Well, you can do what we call turning off unnecessary services. If you remember, I mentioned that some of the services that exist out there are like FTP and then Telnet and HTTP. All of these are unsecure protocols and services that exist, and they are not, more often than not, they should be turned off if they're not being used on that network. So that's one of the first things you can do is you can make sure to remove unnecessary services or unnecessary software or devices. This isn't just services, but if you have a software that is outdated and not patched, you should remove it because if you keep it there, it's a potential attack surface. Okay. Implementing the principle of least privilege. So this is essentially when users and systems only get access to what they need to do, the need to in order to perform tasks. That's it. Keeping software and systems up to date. I think I've talked about this enough in class. Essentially, you have to make sure that it's updated all the time. And then you want to make sure that you have the right security configurations on all of your devices, meaning that you don't just use the default username and password, but you make sure that you update them and that you make sure that you put the right the right security configurations in them. There is something called CIS, which stands for Center of Internet Security. You can look it up, but they have very specific guidelines on how exactly configure your systems to be secure. It's something as simple as saying update your password from the default ones. Isolate sensitive systems. This isolate sensitive systems is exactly what this image is. So you see here, sensitive data. This is considered sensitive information. So you isolate it by putting it in its own zone, and it's also segmented from the network because it has its own switch and it has its own protective mechanism. There's a reason why there are 9 layers of security to access that data, because that data is what a lot of threat actors are after. Endpoint security. So endpoint security is essentially when you put like antivirus on your computer or when you put a firewall on your computer. Now, keep in mind, just like you see here, right? You have a firewall that's on the network, but you don't have to have the firewall just on the network. You can also have a firewall on your host computer at the end computer. That means that if someone bypasses all of these firewalls, if they try to access your computer, well, then you still have a firewall on your computer that could potentially catch it. And then network parameter security. So that just means using firewalls, making sure you have IDS, IPS systems, that's intrusion detection system and intrusion prevention system. So you're doing continuous monitoring. The entire concept of perimeter security is just making sure that you protect from that. Okay. And that's how you do that. All right. Quick quiz question. This answer thread. So A, B, C, or D, the main purpose of implementing a DNZ in network architecture. What is the main purpose of implementing a DMZ in network architecture? We got answers saying B. That is correct. Well done. The DMZ is intended to host something that is accessible from the internet while reducing the risk to the internal network. That's why typically you have the web server that exists on the DMZ. Great job, everyone. Connectivity and network design. So, what is connectivity and network design? Well, in essence, you want to make sure you have a good network design so that the connectivity remains strong. You need this because when you have a well-designed network, it improves the performance of the network, it improves the security of the network, and then it improves the resiliency of the network. As a reminder, resiliency is the concept of being able to withstand events and being able to bounce back in the case of an incident. So, what are the things you have to do? Well, the first thing is you need to do what we call a needs analysis. So, a needs analysis, in essence, is understanding the business goals, how many users you're going to have, maybe how much bandwidth you need, and very specifically, the data flow. The data flow is important because you need to conceptually see where data is going inside of your network so that you know how best to protect it, because some of that data is going to be very valuable. So once you do that needs analysis based on the business, you can then move to what we call security by design, which means that you integrate security from the very start. Remember when I talked about security by design when you're building code? Same thing when you're building a network. You want to not just build the network for efficiency, you want to build the network for efficiency and security. So that's what network by design happens. One of the best ways you can do that is through what we call network segmentation. As a reminder, network segmentation is a concept of dividing your network into different and smaller segments. How do you do that? Well, you use what we call a VLAN, which stands for a virtual local area network. It's essentially putting a logical bucket or guardrails on a specific department. Other ways you can do that is through subnets. So if you've ever talked about IP addresses, you can put them in different subnets that divides them accordingly. And then you can also use what we call physical separation. Physical separation just means putting people in different spaces in the office. That's why some companies that are massive have one entire floor dedicated to IT, one entire floor dedicated to marketing, one entire floor dedicated to sales. This isn't to break up the team in order to not create a culture of like connectiveness. Instead, it's meant to kind of like add different segmentation. Okay. You want to use secure protocol. So that means not using HTTP, but using HTTPS, not using Telnet, but using SSH. You want to make sure that you're using TLS, which is for email and web services. You want to make sure that you're using the right authentication and authorization, meaning that the right people are accessing the right information and they're authorized to do so. We already talked about redundancy and resilience before. We already talked about disaster recovery and business continuity. By the way, this can be an entire career. I know it's just one bullet point, but disaster recovery and business continuity, that can be a career. You can become what we call a BCP specialist. So that stands for business continuity specialist. Business continuity specialist. And that also is in relation to GRC, which stands for governance, risk, and compliance. So if you're ever interested in this, I highly suggest, and if you like things in regards to compliance and law, you can look up business continuity. Other things you can do is include firewalls and intrusion prevention protection systems. We already talked about that. We already talked about zero trust, where you have to make sure to always trust or never trust, always verify, and you need to continue monitoring. Those are the very simple steps of how you can continue to have a good infrastructure. All right. We will talk about this after our break. So I'm going to stop sharing. Farah, let's go ahead and do the duck timer. All right. Okay. We got number 26. Do we have a winner today? We got 27. Amarachi. I think you might have it, Amarachi. We're double checking. Oh, Amarachi and Azibun because you have 25 and 27. Yeah, I think that's it. All right, congratulations. Well done, well done. All right, let's go ahead and pick back up where we left off. Okay, so we had just finished talking about connectivity and network design, and network design is incredibly important so that we make sure to, if we can have better security. The other piece that we're going to go over is failure modes and device attributes. Okay, so what exactly is a failure mode? So a failure mode is when a part of your network essentially dies or it doesn't function as it should. So a fail mode is important because these can happen and they do happen on your network pretty often. So you have to make sure that you have the right capabilities in place to address them or mitigation steps, right? Because what this does is it helps prevent breaches and then it helps bolster up the resilience of your entire network. So when it comes to device attributions, this directly affects like how secure or vulnerable your system is. What do we mean by that? Well, an attribution inside of a device is essentially a feature in the device. Does the device have a lockdown feature if there's unauthorized access? Does it have a booting feature? These are all attributes that the device has which impact the security and vulnerability of said device. Okay, so now let's talk about different types of failures. Well, the first one is called a hardware failure. In very simple terms, it's physical damage to an actual hardware device. So this can be if the disk crashes, if the power goes out, if it's overheating, it just causes unexpected behavior or system unavailability. Now, the reason why this is detrimental is because it can cause downtime, it can cause data loss. And so what you want to do to prevent it is make sure that you have redundant software. Typically, you have one or two of the same softwares so that you can fail over to that software when needed. Then you have what we call UPS, that stands for a backup power supply, as well as different monitoring tools to know if a hardware device fails, then you can go ahead and mitigate it. The next one is a software failure. So software failure is something like Salesforce. So this is a company you should know. So Salesforce is essentially a CRM platform that stands for customer resource and revenue management. So it's where you can track your customers, how much they spend. It's typically used by the salespeople, and it's a really good platform, but it's considered as a software. If for whatever reason the software isn't functioning as intended, so maybe there's a release that has a bug in it, maybe there are some design flaws, maybe there's a misconfiguration, or the application just crashes. Right? So this would be considered a software failure. This is bad because it can open up vulnerabilities or it can stop critical functions. Now, these critical functions are important because a critical service or a critical server is needed in order to keep your business running. If the software doesn't work, maybe that software is the critical software or the critical system and not, and it requires a lot more monitoring. This is why you need to make sure to regularly update it, make sure that you're doing tests on it, and make sure that you have backups or fail-safes. That could even be a light version of this software that can mimic everything that it does, except maybe not as intently. Next one is a network failure. In very simple terms, it's when your network just drops. It doesn't work at all. An example for your network that could totally fall apart is if your main router goes down or any of the switches go down. Because if any of the switches and routers go down, well, then anyone trying to get to your DMZ, any employees that are trying to get to like the data servers, they won't work because none of the switches, none of the devices will be able to get there. So that would be considered a network failure. When that happens, that means that your network is slow or it just doesn't work or it exposes any of those systems. So the way that you mitigate that is you have redundant network paths. So redundant network paths means that instead of just this one path to be able to get to all of this, you'll probably have two or three different paths with two or three different switches. That's what we would consider an enterprise network design because it has redundancy in the paths that it gets to. And the last one is human error. That just means when they use weak passwords or they unintentionally email a different team a very big email chain or email list. So that's pretty common. One of the best ways to handle that is through training. Training, automation tools, firewalls, and just doing a lot of checks. All right. So device attributes. Um, I think for the sake of time, I'll quickly run through this. So first, there's default configuration. So that means that typically when a device is shipped to you, it's shipped with open ports, open services, default logins. You want to update that. And then there's firmware vulnerabilities. That means that if your firmware is outdated, well, then it probably has some exploits. That's why you need to make sure to patch those vulnerabilities and participate in Patch Tuesday. If you don't remember, Patch Tuesday is Microsoft when they release patches, they tend to go out on Tuesday because then it's not the beginning of the week on Monday. Instead, it's on Tuesday so that if any of those patches go wrong, they can revert to the oldest version. And then the next one is network interfacing. So having multiple. That means you should have devices with multiple network paths. That means like multiple routers, multiple switches, different paths to get to the end destination. That's all it means. All right. And then the strategies for making sure that you can address or mitigate any of these failure modes are, for one, you could do a comprehensive risk assessment. That means you make sure to check all the devices, check all the paths, check all of the patch version. There is something in GRC called patch management. Patch management means that you're looking at all the servers within the company and seeing which ones are patched and which ones aren't. And then it is up to the team departments to go ahead and patch them. Then you want to make sure you have a regular patching schedule. More often than not, you want this to be automated. And then configuration management. We'll talk about this later on, so don't worry too much about that. Redundancy, we already talked about. User training and awareness, we already talked about. And then security by design, that's building security at the very start of the network. So meaning you don't just build the network to be efficient, you build the network to be secure and efficient. And the last one, we already nailed that hammer in, network segmentation. Okay? So these are all the ways that you can address the failure modes and the different device attributions accordingly. Okay, port security and authentication. So what is port security? Port security is, well, before we do that, I think we should talk about the layers. When you talk about networking, when you work in cybersecurity, one of the first things that you'll learn is something called the OSI model. So the OSI model, for maybe this, you've already seen this, but this will be a refresher. It is a 7-layer logical concept. Okay. What do I mean by logical concept? That means that it's not a physical layer, but it's a logical layer that is used in networking and in IT to be able to like talk about the different features. So every network has 7 layers. If you haven't been paying attention to the lecture so far, this is what you need to pay attention to. You will have to memorize this for your Sec Plus exam. Okay. So I highly suggest that you take notes on this. You're aware of it. Okay. Now, why is this important? It's important because each layer represents a very specific piece of networking. And the way that I like to remember it is please do not throw sausage pizza away. That is the way to remember the OSI layer. Now, other instructors may tell you another way to remember, but that's how I remember it. It's please do not throw sausage pizza away. Now, the reason why is because everyone loves pizza. Okay, great. You already know about the OSI layer. Well, then I shall continue. So when it comes to the OSI layer, we're mainly looking, when it comes to port security, we're looking at layer 2. Layer 2 is the data link layer. Okay, so the data link layer is where you find all of these switches. Okay, so when it comes to switches, switches tend to work off of what we call MAC addresses. Now, a MAC address is not like the Mac, like an Apple Mac computer. Instead, it's a very unique identifier to the actual device itself. Okay, so the MAC address tends to be an alphanumeric, which is from 0 to 8 and A to H, I think. Oh, the eighth letter of the alphabet. But it typically looks like this. So the reason why is because each device has a unique MAC address that allows to switch to dynamically know where the device should go. Okay, where the device, if a device is allowed to access a certain thing or not. Okay. So MAC address limiting, it only allows certain MAC addresses to proceed forward. That's what MAC address limiting means. Sticky MAC addresses means that it learns the device's MAC address and keeps it as trusted. That's another way of saying it is dynamic. There is something that we call violation modes that exist on the switch. A violation mode is essentially if if one of the people that are trying to access that switch is in violation of the rules, it'll take one of 3 actions. So the first action in violation is protect. That means that it drops the unauthorized traffic silently. It doesn't do anything. The other one is restrict. That means it drops the traffic and it logs an alert. And the last one is shut down. That means it disables the port entirely. Now keep in mind, we're talking about switches here, right? Because we're talking about the data link layer, layer 2. Each switch has specific ports that allow a specific service. As a reminder, a port is a specific lane dedicated to a specific service. For example, email has a very specific port, and internet has a very specific port. RDP, which stands for Remote Desktop Protocol, which allows you to log into a computer from like your home, has a specific port. It has very dedicated ports, and each of those ports have violation modes, meaning if there's unauthorized traffic on the email port, well, then on that switch, it could either just drop that traffic, it could restrict that traffic, or it could completely shut that port down. The reason why these violation modes are important is because you as a security professional can set which violation mode depending on how important that port or that service is. Okay? All right. Now, when it comes to port security, this is in regards to access control. It controls who and what can connect to your network. This is typically done at the entry point. The entry point in this case would be the router and the switches. So these are the two entry points where you'll typically have port authority to be able to allow or disallow access to a certain resource. So there are these are some considerations. There's something called dynamic and static configuration. This means that you can manually assign a MAC address, so that's called static, and then you would have to update that on all the switches. But then there's also the dynamic version, which means the switch learns the MAC addresses accordingly. That means that if I have a new device, like a new computer with a new employee, I can manually go into each of the switches and update the MAC address saying, hey, they're allowed to access this. Or you can dynamically allow the switch to learn it. Now, as you can imagine, this one, static, is very resource and time intensive. Whereas the dynamic version allows the switch to learn it automatically. So that's the option that tends to be picked more often than not. Now, let's say you have one of your switches experiences a violation. Well, if it experiences a violation, especially if it's a shutdown, well, then you'll have to manually boot it up. Okay. Whereas all the other ones, such as dropping unauthorized traffic and logging an alert, it doesn't really do anything. Shutdown is the main one that needs an actual recovery. And the last one, regular audits. So regular audits just means that you want to make sure that you double check the port security of all your switches regularly. Typically, this can be done with a central management platform, which we'll talk about here in a bit. Authentication. I'm going to go ahead and define this in very simple terms. So authentication is verifying that a user or a device is who they say they are. That means that they're legitimate and they're allowed to be on the network. This is around the concept of never trust, always verify. So the zero trust, okay? So there are a lot of common protocols that you can use in order to do that. One of them is 802.1x. You will have to know this, so I do suggest you write this down because this does come up. So 802.1x is essentially how do I say this simply? It's just a way for you to authenticate that device, okay? And then there are other ways to authenticate it, such as EAP-TLS. So this is when you're using certificate-based. This is very secure, one of the best options. And the other one is PEP. So that's in regards to encryption. So it's username password over TLS. Okay? So if you want to implement authentication based off of this, well, then one of the things that you have to do is you have to decide which networks or zones require that 802.1x authentication. Now, this 802.1x, when you're actually configuring a switch, you do have to type out 802.1x. I believe you'll be doing that in one of your labs. Then you want to make sure that that device is compatible with that authentication mode. Some of these are not, some of them are kind of old. And so you want to stick with the newest one, which is 802.1x. You want to make sure that you set up guest access. So as you can imagine, every organization has their internal Wi-Fi, and then they have what we call their guest Wi-Fi. That guest Wi-Fi is essentially that guest Wi-Fi is essentially what like contractors or visitors would be using so that they don't have access to the internal network. All right. I think that touches on that. Okay. This is a really good slide because everyone here needs to fully understand what a firewall is. One of the first things you'll get asked as a cybersecurity professional, maybe in an interview, is what does a firewall do? Well, in essence, a firewall objectively is a device that is meant to monitor and filter out incoming and outgoing traffic. So a firewall tends to have a lot of complicated rules in it. They have a rule set that allows or denies traffic based off certain criteria. Think of it as like a barrier between the trusted network and the untrusted network. Now, as you can remember, when I showed you this diagram, let's make this one a little bigger. That way you all can see it and I can zoom in. So here we have the general internet, right? But you have one, two, three, four, five different firewalls. You'll notice that the firewalls are typically connected or right next to an entry point. The entry point is an edge or a switch, okay? And so these firewalls have very specific rules in them that filter out or allow traffic as needed. All right. So now that we understand a firewall, I want to kind of switch it up. As you remember, I always try to have you try to explain some of these concepts to family, friends, that so that you understand it better. So my question is, how would you explain a firewall in your own words to a loved one or a friend? So I just put that in the chat. Please go ahead and answer on the thread using your own words. You don't have to use cybersecurity words. You don't have to use technical terms. Just use words that you understand and that make sense to you. I sometimes like to call it, it's a fishnet. It allows fish to go through that are too small that we don't want to catch, but it catches the big ones. Or it allows small fish to go out, but it catches the big ones. Very simple term. So how would you define a firewall? Water filter. Yes, Abdul. Screening at the airport. That's a really great one. Yep. Allowing or disallowing. Traffic monitor, a filter, a device that, yes, a barrier. Filters out impurity. Pardeep, that was perfect. Wall to prevent unauthorized access. That is correct. That is exactly why we use the firewall image, is to allow or not allow. Checkpoint, screening devices. Tech control, which filters traffic. These are great answers. Allow what you know, and what you know is good. Everything else is burned down to ashes. That was funny. Guard, Sylvester said a middleman. Network security. Great job, everyone. These are all great answers. All great answers. Okay. So let's talk a little bit more about types of about some firewalls. Now we have what we call a packet filtering firewall. Now, if you remember the OSI model, right? Layer 3 is the network layer, right? So we deal with like uh routing traffic specifically, right? So in the network layer, we have packet filtering firewalls. Anytime we're sending data through the network, it's in packets, right? So it functions on layer 3, and what it does is it filters traffic based on IP address, port number, and protocol. So IP address is like the IP address of the device it's trying to reach to. The port number is the port and the service slash protocol it's trying to use. Okay. The reason why this is nice is because it's simple. It doesn't take much resource. The only bad thing is that there's not really any context or session awareness. So there's not much visibility into that. Then we have what we call a stateful inspection firewall. So a stateful inspection firewall doesn't function on layer 3, it functions on layer 4, the transport layer. Now, the transport layer I always think of as like a bus because it's literally what carries or transmits the protocol. Now, it can take two lanes. The transport layer can either take a TCP, which is more secure, which has the three-way handshake, or UDP, which I like to think of as YouTube because it just sends the information. I don't know if you know, but anytime you watch a YouTube video, well, then those frames are just being sent to your computer. They're not actually being checked. They're not actually being verified because UDP cares about speed. TCP cares about security. Okay. So when it comes to stateful inspection, what it does is it tracks any of the sessions and then it makes decisions based on the traffic state. Okay. So the benefit of that is that it's stronger when it comes to packet filtering. It gives it more data and more information to filter through the packet. Now, the bad part is that it does take a lot of resources. A lot of resources means that the performance of the network could be a little slow if you have a lot of firewalls that are inspecting all of this data. The way that it's inspecting the data is it not only looks at like the destination IP and port number, but instead it looks at the destination IP, the port number, the sequence of acknowledgement from TCP headers. It looks at the three-way handshake, so SYN, SYNACK, ACK. It looks at everything and tends to dive a little deeper. The other one is application layer gateway. So this functions at layer 7. That's the application layer. So the application layer is the human interaction. Our eyes can actually see what's happening. That's what layer 7. Anytime you're interacting with a computer, you're interacting with layer 7. Everything else is behind that layer 7. So in this case, it's a proxy firewall. Now, the proxy firewall, it intercepts traffic and it acts kind of like a middleman between the user and the service, right? A proxy is kind of like that middle person, right? The benefit is that it inspects the full content of the traffic. And then it's really great because it's able to filter applications based on if it's like FTP or HTTP, okay? That's all it does. It's kind of like the middleman. The bad side is that it's a lot slower. This is one you're going to hear very often. This is called a next gen firewall, NGFW. This is very common now. A lot of businesses have it. Now, the benefit of this, and you'll see why, is because it's stateful inspection, meaning that it does a lot of reading into all of the destination data, where it's going, the IP address, all that. And it typically includes what we call the IDS and IPS. Reminder, that's intrusion detection and intrusion prevention system. Okay. Not only does it do deep packet inspection, it has that, but the application tends to learn and understand where these packets are coming from. So these packets are well inspected and it provides a high level of security. This is one of the reasons why next generation firewalls exist, is because they're so dynamic and so secure. That being said, as you can imagine, just like how stateful inspection firewalls take a lot of resources, so do next gen firewalls. They tend to be expensive and they tend to take up resources, as well as the fact that you do need to have very knowledgeable professionals to be able to configure and work with them. Okay? So that's why there's a level of complexity there. And the last two is a UTM, that's a Unified Threat Management Firewall. So a UTM, in very simple terms, is it combines a firewall with an antivirus, VPN, anti-spam, and content filtering in one box. That's why it's called Unified Threat Management System. It's an all-in-one solution, and it's really nice because it's really good for small, medium businesses, because then they don't have to invest in each of these individual solutions. It's just all in one. But it's not that great because it's not as flexible. So it's not as powerful. It just does the very basics of a firewall and antivirus, but it's limited in its customizability. And the last one is Web Application Firewall, so a WAF. So that means that it protects the web applications, so on layer 7, from attacks that are specifically like SQL injection or XSS. So XSS, that stands for a cross-site scripting attack. Now, a cross-site scripting attack is essentially when it's specifically for a web application where someone can inject malicious script onto the website. It's typically when there's a place where you can input certain amount of text. So like a user can type something in, they can input a script that has the web application do an action it's not supposed to. So these WAFs, web application firewalls, are essentially meant to protect the web application or the web server. That's its entire goal. Now, its entire purpose is that it's meant to protect it, but it needs constant maintenance. It needs constant review. Wajia, I see your question. So it depends. I have seen a lot of organizations use a next generation firewall nowadays. That's probably the one that is used most often. And then Muslehuddin, I see your question. Yes, a next generation firewall is typically what a lot of the big organizations use. However, I will say that a big organization uses next generation firewall as well as web application firewalls, and then at times proxy firewalls. Now you can see that here, right? You have a proxy server, right? Now, you could have a proxy server, and then right before it hits this switch, you could have a proxy firewall, okay? Because then it limits that connection point. All right, we have a couple more slides to go here. Okay, now, you remember when I was saying if you have a really big network, if you have a really big um, list of devices, computers, and things that you need to manage properly, well, then you can have a software that is able to manage or kind of like take care of all of those, right? So that is where a software-defined wide area network comes into play. What is that? So it's when you use software to manage and control your network. That's all it is. That means that instead of going into each of the devices individually, such as if I were to go into this device, right? This is my network, let's say. In my network, I have this edge router, I have this firewall, I have this switch, all these servers, all these workstations, all of these devices. If I didn't have a software to automatically manage them, or for a very simple example is a very simple example, such as let's say updating or patching them, I would have to manually, as a resource, go into each of these devices individually and make sure they're up to date with the most recent version. That is painstakingly long. But if I have an SD-WAN, well, then I'm able to essentially optimize that process and I can optimize the traffic over all the different connections. All right. So think of it as like a centralized control panel that improves the performance, flexibility, and overall security of the entire network in and of itself. So what it does is it can dynamically route traffic. It can do routing based on different applications, and it can centralize management. So admins can configure, they can monitor their network and essentially simplify the operations. It's like having a control hub or a control panel for your overall network. So, what are the benefits? Why do we want this? Well, the benefit is that you have dynamic path selection, meaning that it can learn where the paths go. You can reduce your cost, and then you can essentially have stronger security because it saves you some time. That's why agility is on there as well. It increases your ability to scale and reconfigure your network as needed because you're doing it through a software as opposed to manual. All right. So you have your network. So in your network, you have this software that you want to use. How do you implement it? I will dwindle this down into three easy steps. The first thing is you want to assess your network and how it's doing. And then you want to find a vendor that is able to integrate with your network and integrate with your infrastructure. And then you want to make sure that that vendor can integrate with your current existing security tools. That's an important one. If you buy a vendor that can't integrate with your systems, well, then that is another workaround that you have to figure out. So you need to make sure that it integrates with your system. And then you need to make sure that there is adequate monitoring and adequate security, training, and support. Those are the ways that you implement the software. Keep in mind, when you buy this software, if you remember our last class, they're considered a third-party vendor. So if they're a third-party vendor, you're giving control away, but you're giving control away at the cost of being more efficient. So as a business, you have to balance that out. It is so much more secure and so much more cost effective to use an SD-WAN though. Now, there's also another service called a Secure Access Service Edge, a SaaS. Okay. I think some people call them SaaSes. I call it SaaS. So what is a SaaS? In essence, it is a cloud native architecture, meaning that it's mainly in the cloud and it merges networking with security into one main service. Okay. So it's really important because in today's world, a lot of people are working remotely. So when you're working remotely, you're working a lot with cloud. So why not combine networking and security into one coherent one coherent location? Now, there is a company called Gartner. If you're not aware of Gartner, Gartner is a company that does a lot of great research on the different like movements that are happening in technology. They're the ones who coined it back in like I think 2019. Yep, 2019. And it's kind of like a next gen approach to security access. Quick note, anytime you hear the term next gen, the first thing that should come to mind is like new. That's all it means. It's new. So what exactly does a SaaS do? Now, a SaaS combines all of the key elements in cybersecurity and network. So it brings together a SD-WAN, so like the software where you're able to manage your networking. It brings together a firewall. So there's something called Firewall as a service. It's like a cloud thing. It brings together like access control, zero trust network. It brings together like secure web gateways. It puts everything all under one big umbrella. So it's based all of this on the user identity, device context, and location. Instead of looking mainly at the IP and network location, it goes more broadly and more beneficially to the users and the devices. So, what are the benefits? Why is this important? Well, I'll tell you one thing. When you have a SaaS, you have essentially security everywhere. That means that it applies consistently across all your security policies, no matter where the users are. This is powerful because when you're remote, well, then there are some barriers for you as an organization, right? Whereas when you're using SaaS, it essentially puts a barrier or security dome over everything. The other piece is that because you're just having one solution that combines everything, it lowers the complexity and the cost. You have one vendor, one interface, and then you don't have fewer standalone tools that you need to integrate with one another. Instead, it's all combined into one. What that does is it makes sure that you have better performance overall, both from network and security marketing, and then it optimizes general bandwidth. And last but not least, these SaaS tools, being like somewhat recent, tend to be future ready, meaning that they can scale. What I mean by scale is a lot of employees are looking to work remotely. So that allows them to do that. Not just that, but it's easily installable. So if you work in an organization where you can bring your own computer, well, then it's easily installable onto that. How do you implement it? Well, in short, you essentially do an assessment of your infrastructure. You do the same thing you do before. You do a vendor assessment, making sure that they're able to integrate with all your other tools or replace all your other tools. And then you do what we call a phased deployment. So the phased deployment piece means that you don't implement it all at once, but you do it bit by bit by bit by bit. Okay. And then you have policy and governance. You need to make sure that it adheres to all of your compliance standards. Some compliance standards require you to have um, a dedicated tool just for network management and not like a tool that does everything. And then you need training and change management. As a reminder, that means that you are shifting the employee's focus from just like individual pieces to one master one. All right, let's carry on. Okay, now let's talk a bit more about strategic controls. Now, this is where we're going to dive a little deeper into some of the different layers. Okay, what is a strategic control? Now, a strategic control is a very selectively picked security tool or practice that is specific to the network architecture. And in this case, we're mainly going to focus on two, layer 4, which is the transport layer, and layer 7, which is the application layer. As a reminder, layer 4 is the transport layer where we are transporting data and packets via a specific lane, TCP or UDP. Layer 7 is the application layer. It's where our eyes meet the screen, where we can see the actual application. Now, as a reminder, again, when we're talking about applications, I know the first thing that comes to mind is a phone application, but an application can be any technology that serves a specific service or function. For example, you can have a web application, which is a website. You can have an application service that does maybe it converts a PDF to like a Word document or vice versa. Okay, that's what we mean by application. Now, the entire point here is it helps tailor the defense based on the traffic type or and business priority. Now, what does that mean based on the traffic type or business priority? Well, as you can imagine, each business has their own needs. They have very specific things that they want to do and very specific things that they don't want to do. So, with that in mind, they have to make sure to focus on certain layers and certain services. This is why we're highlighting layer 4 and layer 7. So, that being said, let's kind of dive into that right now. Give me 1 second. I need to pull up something here real quick. Make sure we have that ready. Okay. This is module. Okay. All right. I want to make sure that I have your Kahoot up and ready. That way we don't have to dilly-dally too long. Let's see. Give me 1 second, everyone. Okay, there we go. Okay, we are good to go. All all right. This is to give you guys a little life so you know that the end is coming. So let's talk a little bit about layer 4 and layer 7. So here we have a here we have a process called encapsulation and decapsulation. Okay. Now, in very simple terms, right? layers, these are the 7 layers of the OSI model, right? It's please do not throw sausage pizza away, okay? And at each level, there is something that adds a tail or a header to the data. So here we have the data, right? It starts at the application layer. So there's data at the application layer that's trying to be sent to another user. So that data is then sent to the presentation layer, which adds on another header, to the session layer, which adds another, and then to transport another, so on and so forth. The encapsulation process is giving the data additional data. It's giving it additional identifiers so that we better understand where that traffic is going and what it's trying to do. Okay. So layer 7 is essentially layer 7 is essentially meant to analyze the full content of the traffic, not just the headers. Okay. So it can understand the application layer behavior like form submission, logins, that kind of stuff. Okay. So this is what the entire process, encapsulation and then decapsulation. Okay. Where here you sent the data, each layer says, hey, I need to go this way. Hey, I need to go this traffic. Hey, I need to go here. And then it ends up in the application layer. So okay. So layer 4 here, it is focused on the transport layer. That means that it focuses on things such as IP addresses, ports, and traffic sessions. It essentially is focused on understanding where is the data going. It operates using, like I said before, TCP, which stands for Transmission Control Protocol, and UDP, which stands for User Datagram Protocol. Now, if you're going to remember anything on top of like the OSI layer and like port security, one of the key things to understand is TCP versus UDP. TCP is secure. UDP is not as secure. TCP is slower, but UDP is faster. The way I remember that is UDP is similar to YouTube. YouTube is meant to be fast. You just send the data and you go. TCP is secure because it does a three-way handshake. So layer 4 operates and mainly focuses on TCP transportation. Okay. So what are the characteristics? Well, you have port-based filtering. What does that mean? That means that it only allow needed services. So only allowing the most important ones, such as it blocks FTP, which stands for File Transfer Protocol, which is port 21, means that it blocks it, and it only allows secure ones, such as SSH or HTTPS. Port filtering, all it means is we're blocking unneeded or unuseful ports. We're only allowing the most important ones. And then there's stateful firewalls. So like we mentioned before, that means that they track the connected states to allow or block traffic. That's all it means. And then load balancing. Specifically, this is layer 4 load balancing. As a reminder, load balancers are a device that allows you to route traffic in a way that is secure and in a way that doesn't overload one specific system. So it distributes traffic evenly. So why is layer 4 important? Well, layer 4 is important because it tends to be fast, it tends to be lightweight, and it tends to be effective when it comes to overall traffic management. It reduces like a lot of the bandwidth. So that's layer 4. That's why it's an important one for people to focus on. And then layer 7. So layer 7, like I said before, it it analyzes the full content of the traffic, not just the headers. Okay. So what it does is it tries to understand application behavior, such as if you have a web application, you have a form, it says give me first name, last name, email. So it looks at the form and it says, okay, what did the person input into that form? It analyzes it to make sure that, hey, is there a cross-site scripting attack trying to happen, right? It looks at the login. If someone enters username and password, it analyzes that username and password to make sure that it's accurate. And then file uploads. Okay, so it's kind of like a full It looks a magnifying glass looking at in depth into the actual content. So what are some ways that you can protect it? Well, one of them is called deep packet inspection. So deep packet inspection, also called DPI, it's where it has advanced malware and advanced application layer detection. So that's all it is. It's just looking more deeply into those packets to identify anything that could be malicious. The other one is a WAF, like we had talked about before, Web Application Firewall. Now, as you remember, a web application firewall is to protect against SQL injections or cross-site scripting. Cross-site scripting is when you input a script into the form that we had talked about before. And the last one is application aware controls. This is just where it blocks access to specific services. An example, there are a lot of companies right now who are very wary of TikTok. And so they have application aware controls and policies that don't allow TikTok traffic to operate on their network. Sometimes you'll try to use TikTok or social media and it won't work. The other way that it protects it is through data types. So a data type is if someone is trying to process clear and unencrypted credit card numbers. So there will be a way for them to track it and to essentially block it. Application aware controls is just meant to not only allow certain traffic and certain data. So what are the differences between layer 4 and layer 7? Let me do this. I'm going to give you all a nifty little graph that I made for you all so you all can have it to make your lives a little easier. So when it comes to layer 4 and layer 7, an easy way to understand it is that layer 4 is focused on ports, IPs, and sessions. And then layer 7 is focused on application, the content, and user behavior. Now, the performance is that layer 4 tends to be fast because it tends to have devices there that allow it to manage the network, whereas layer 7, because it's doing so much inspection, because it's ingesting so much data, it tends to be a little slower. Now, just because I'm saying it's slower doesn't mean that it takes like hours. To us, milliseconds can be a lot when it comes to networking. So keep that in mind. When it comes to security, both of them are pretty detailed, they're pretty broad, but layer 7 tends to be a lot more granular and a lot more detailed, whereas layer 4 is just basic protection. And the use cases are generally that layer 4 tends to have general controls, whereas layer 7 tends to be like web application protection and data filtering. Okay. All right. So when you're a business, you might have to look at the 7 OSI models or OSI layers and decide which layer do we want to invest a lot of our time and energy into. Okay. Um, so the benefit is that you don't have to just pick one. More often than not, businesses will pick several. So they pick layers that can be together. So we have what we call the OSI model, right? But then we have the IP model. So the IP model layers it's the same thing as the OSI model, except it's quote unquote more revolutionized. Instead of 7 layers, they tend to have 4. And it typically combines a lot of them. So transport layer stays the same, application layer stays the same, but all the other layers tend to get grouped into these two different areas. Okay. So you can look this into this if you want, because this is the type of model what we mean when we say when you make a strategic decision, you layer them together. You don't just pick one or the other. They typically work together in unison. Okay. So what you want to do as a business is when you're trying to pick where you're focusing, you want to make sure that you're okay. You want to make sure that okay. Yeah, you want to make sure that you're picking according to what your team needs. All right. Evaluating security measures based on requirements. Now, what this slide here is saying is it's essentially saying every organization is different. So every organization has to decide where they're going to prioritize their efforts and their money specifically. That means they have different regulations, they have different infrastructures. Some companies really care about protecting their data. Some companies really care about protecting their application. Overall, they have different risk profiles and regulations that they have to follow. Okay. So you have to choose the controls very efficiently so that it doesn't waste time, money, or leave any gaps. That's all this slide here is saying. Now, I will let you all dig into each of these in and of themselves, but in essence, I would summarize all of this by saying, do your due diligence. As an organization, you have to understand, A, what does my organization do? What kind of data does my organization have? What are the risks of the things we do and the data that we have? What are the threats that could impact us? Are there any compliance requirements that we need to adhere to? And then based off of those five things, you can then start thinking, what are the controls I can put in place? What are the critical systems and services that I need to protect? From there, you can start implementing it. And then at the end, you want to make sure you do continuous improvement, continuous monitoring. That's what this slide is saying. Do your due diligence based off what your business specifically needs. All right, VPN. So a VPN is something that's also really important for you as a cybersecurity professional to know, because I always like to define it as a tunnel. A VPN is a secure tunnel over a public or a private or an untrusted network. That means no one can see the actual traffic. It encrypts all the data that's being transmitted between like two users or two devices so that someone can't see in between them. So does it mean when applying firewalls, it can only be applied to one layer, not all seven layers? That's a great question. And that is a complicated answer because you have a layer 3 firewall, a layer 7 firewall. You have firewall that can be put at the physical level. It's a very complicated answer, but I'll let the TAs kind of like dig into that a bit more because we're running short on time here. So a VPN, it's a tunnel that protects your data, protects anyone from being able to see it. It encrypts that information. Okay. So a VPN is one of the most important tools that you'll need inside of cybersecurity because it makes sure to protect your data when you're transmitting it, especially if you're working from home. Typically, when you're working from home, you'll be required to get on a VPN in order to do your work. So what it does is it connects your home to the actual office branch. It allows for remote work and does so securely. And it allows you to do private browsing on public Wi-Fi. Should you be using the public Wi-Fi? Probably not, but sometimes you have to. So that's why I always say anytime you go to a coffee shop, turn on a VPN. I already gave you all one of those VPNs options that you can use on your own, but yeah. So a VPN, you can define if you need it or not. I'll tell you right now, a lot of companies do need it. Then you have to choose the right VPN for you. So there's a remote access VPN. So this is the most common one used by remote employees right now. So it's when an individual needs to connect to the corporate network. So internally, there's site-to-site VPN. I don't see that often. It's connecting an entire network to the actual internal system. So if it's like you have two branches, right? The branches need to connect to each other so they can share data. That's all it is. It's like site to site. And then clientless VPN, that's when you use a web browser to access applications. So you don't use an actual software or whatnot. You just use the web browser. The web browser will most likely have an actual authentication that will have MFA listed on it and whatnot. After that, you have to pick your VPN protocol. So I also made you all a little graph for that because I know this can get a little complicated. So hopefully this makes it a little easier for you all. In essence, you have IPsec, SSL TLS, and OpenVPN. IPsec is used for site-to-site or remote access. And It has really strong encryption. It's used everywhere. SSL is also used a lot, but it's mainly focused on web applications and HTTPS. Finally, OpenVPN. That's where it's flexible, both remote and site to site. It's open source, so it's very flexible and it tends to be highly secure. Obviously, we talked about MFA. That's important. So digital certificates are what are used for devices to verify each other, verify their identity, and say, "Hey, am I allowed to connect to you? Yes, I am." Or on VPN, where's your digital certificate? Got it. Good to go. A lot of these authentication methods, they require username, password, as well as MFA. And on the back end, that's where the digital certificates work. More often than not, a lot of these VPNs use the best in class encryption, which is AES. That stands for Advanced Encryption Standard. We will most likely go through those a little later. And then they do require MFA. You typically want to have IP addresses only accessed by certain IP range or group, meaning that only certain people can have access to it. All right. And down here to educating users, it's very important that you make getting on the VPN a part of your culture because one of the best ways to be secure is when security isn't a choice. It is built into the actual setup. So the best option would be once a user logs in, they can't do anything until they are on VPN. And that typically just requires like a finger scan or a login or something like that. And then you want to make sure that you have training sessions that are readily available for them to look at in case you say, hey, how do I access a VPN? That kind of stuff. And then you just need to monitor and maintain it. All right. Remote access protocols. So I think for this, I'm only going to focus on one piece. So remote access protocols is when if I'm at home and I need to access a server at work, I can use a remote access protocol in order to get in. The one that I really want you all to remember is SSH. That stands for Secure Shell. Essentially, it's when you're using a command line interface, so like that black screen with the white or green text, in order to remote into a server. Okay. The reason why this is good and why it's the best in class is because it uses strong encryption and strong authentication. Okay. So that's the main one that I want you all to remember is SSH. And your homework, not you don't have to turn anything in, but I encourage you to look up SSH and look up also something called RDP. That stands for Remote Desktop Protocol. So it is a Microsoft specific one because it allows the user to connect to another computer on a network. But look up RDP and SSH because these are two things that you want to know. And if you go on to, I would say go on to YouTube and look for SSH or RDP from someone. Oh, shoot. I'm forgetting. Professor Messer. Professor Messer is a really good person, or Network Chuck. Look up, look up SSH and RDP from Professor Messer or Network Chuck. They both have great videos. Network Chuck is very entertaining. So I suggest you check that out. All right. Okay. We're doing good here. Just two more slides. So there's also TLS. So TLS stands for Transport Layer Security, as you can imagine. This is around layer 4, the transport layer. And it's essentially a protocol that's cryptographic in nature, where it provides confidentiality, integrity, and authentication. The entire goal of TLS is to make sure that information stays secure, no information is changed, and that whoever is accessing said information is allowed to access it. Okay? That's all there is to it. And let me put this last little thing here for you all. And hopefully I'm breaking this down in an easy to digest manner. I'm trying to make it so that it's less wordy and more straight to the point. Hence why I made some of these, okay? I'm gonna skip the implementation steps for now. All right. All right, let's get into the quiz. Actually, you know what? We're gonna, yeah, let's do it. I think it's important. Quiz thread. All right. So, question one. Which of the following best defines return on investment in the context of cybersecurity investments? A, B, C, or D? A lot of people fearing A. Well done. That is correct. Question number two. What is the primary purpose of IDS and IPS in cybersecurity? IDS and IPS. Got a lot of answers for B. Well done. And question number three. What layer of the OSI model does port security operate on? Port security. What layer does it operate on? A. Well done. That is correct. Last question, or two more questions rather. What is the primary purpose of 802.1x authentication in networking? 802.1x authentication. All right, that's right. We're talking about authentication, so it's authorized users. And last one, which layer of the OSI model is associated with TCP and UDP? All right, well done. It's the transport layer. Okay, now to summarize everything up, when we're talking about security architecture, right? I know that this was a really heavy class where we focused pretty heavily on networking and pretty heavily on the devices. But if you're going to take away anything from here, understand this. The foundational design of cybersecurity architecture needs to align with the business needs. It needs to align with the availability that the business needs to have. Hence why you prioritize and focus on certain servers and services. That being said, it's all aimed at keeping the availability, resilience, and yeah, the availability and resilience of your service. You have to do this with the idea of security by design, meaning that you're implementing it from the ground up. You want to make sure that it's scalable so that you can grow as needed, and you want to make sure that it's easy to deploy. Now, as an organization, keep in mind, you have to do all of this, keeping security in mind and everything at the right cost. You have to find the right cost and the right investment and how much to invest where. A key element of a good security architecture is good research, understanding what you do, what you have, what you're processing, and how to protect it. Once you understand what you have, then you can talk about, hey, I think we need firewalls here. I think we need a next generation firewall. I think we need a SASE to maintain everything and have a central control unit. I think that we need to have more access control, or we need to include some final VPNs and whatnot. Okay. So a couple final thoughts. Even though we're talking about security architecture, I think you can all understand now that it's not just about the tech. You also have to think about the design of your system. Like we talked about, different zones, right? I feel like this image right here is probably one of the most useful images you'll have out there because it breaks down the device and security layout so that you can really know where things go. Okay. All right. I think we have 8 minutes left. So let's go ahead and finish. I will say this. Layered defense is best, and you don't want to have a single control of failure. Yeah, I think we're good. Okay.